more of properties of logarithms using those to solve log equations. So I wanted to review, these are the first two properties that we used yesterday on our assignment, and mainly the new property was the one-to-one property, so we want to make sure that we don't forget that. But I also wanted to review properties of logs, the addition or multiplication property, quotient, power, and change of base. So I put review on all of these because technically we should be good on them, but we want to remember all of those when we're asked to solve the following log problems. Now, before we get to finding the actual solutions, I wanted to take a second to review how we find the domain restrictions of each one. That's going to be important because if we get solutions, doesn't necessarily always mean that those are actually going to satisfy the equation. They may be in a restricted domain, and so we'll have to exclude them from our solution set. So I'll talk about that here in this one. Let's say in number one, I'm not even asking you to solve, I just want you to state the domain restriction. So to do that, you have to look at the domain restrictions of each log part that you see. So what would that look like? Well, let's look at the first one. Log of what? Well, log of x. And what do we know about anything you take the log of? It doesn't matter that this is base 10 right now. I could have put base 12 on all of these, or base 50. It doesn't matter. What would be the log of x, and what would x have to be? Well, we know that whatever we're taking the log of, in this case is x, has to be not 0 and greater than 0. So that's how we establish that. What about this next one? X minus 1. Well, whatever x minus 1 is, it has to also be greater than 0. So let's do a little simplification. So x has to be greater than 1. What about on this last one? 3x plus 12 has to be greater than 0. Solve, you'd subtract the 12 over, divide by 3. You're going to get x is greater than -4. So I have these three restrictions. How do I know what is the domain restriction for the overall equation? You look for the most restricted region. So I kind of did this yesterday. So 0 would be here and this way, right? 1, here's 1. 1 would be here and this way. And -4 would be here and this way. So which of these three have all of those restrictions included? Do you see this region right here is the only thing that has all three of those restrictions included in them? So how do you describe that? Well, that would be this region right there. So even though you get all three of those, you have to choose the one that will have solutions in it that work for every single individual log part. So keep that in mind. That makes sense because, hey, if I get x equals -2 as a possible, solution, it actually isn't going to work because it only works for this top one. It only works for greater than -4, right? Does not work for the other one, so we'd have to exclude that from our solution set. Keep that in mind. All right, solve the equation using the variable. Solve the equation for the variable. Check your solution to make sure it's not in the restricted domain. So how would I do this? Well, you can use those properties of logs I reminded you of, and then use everything else we did yesterday. So what am I going to do with 8 and x? I'm going to multiply them because I added them and there's the same base. Now from here, what do I do? Well, I don't have another log with the same base on the other side, but I can change this back into exponential. The base here is 10, even though it's not written. So 10 to the second equals 8x. That would give me 100 equals 8x. Divide, I get 100 over 8. If you wanted to round, that's 12.5, but just listen to directions on the homework, depending on if I ask you to round or write as a decimal or write as a fraction. What about over here? Well, it's the same type of setup, I'm just dividing this time. So keep the same base, but this time it's x over 2 equals 1. Now change it to exponential. So that's going to be 6 to the first equals x over 2. I want to solve for x, so I multiply by 2 on both sides. And that gives me x equals, I kind of didn't do this step, but you guys cool, 6 to the first is 6, and then times 2 is 12. Now, there's something that I've actually forgotten to mention on both of these steps. Make sure you always go back and you plug in for that variable, right? And make sure you're not going to get a negative or 0. Well, it's pretty easy since you just have x in both of those, that 12 is not 0 or negative, and 12.5 is not 0 or negative, so you're good on those. But always check that. There will be situations where you get those extraneous solutions like I mentioned. So how about this next one? Well, this is the one I just asked you to state domain with, but what am I going to do in this case? Well, I have to simplify this left-hand side first. And how do I simplify it? Well, it's addition, so I'm going to multiply x and x minus 1. So this gives me log of x squared minus x equals log of 3x plus 12. Now what do I do? Well, since I do have logs on both sides, I can set these parts equal to each other, right? So I get x squared minus x equals 3x plus 12. And then this is going to be a quadratic. So how do you solve a quadratic? You get every term on one side equal to 0. So if I did that, I would probably subtract the 3x over and I'd subtract the 12 over. Simplifying that would give me x squared minus 4x minus 12 equals 0. I'd go ahead and factor this. So that would give me what? X, let's see here, x minus 6, x plus 2 equals 0. So my two solutions right now are 6 and negative 2. Now before I go circling those as, oh yeah, those will work, you have to go back and check to make sure that they all work in your equation. So do you see any that will fail? So where will the 6 fail? So I'd have log of 6 plus log of 5, you guys see where that's coming from, 6 minus 1, equals log of 6 times 3, 18, plus 12, 30. So not going to fail with the 6. What about the negative 2? It will, in fact, it will fail here that I'm circling and here, right? Why? Well, you'd have log of negative 2 and you'd have log of negative 3 there. This is an extraneous solution. Your only solution is x equals 6 here, okay? What about number 5? Well, as you can see, I've got natural logs in there, but I can't just go ahead and set the left side equal to the right because I got this minus 5. So we want to put all of the logs with the same base on one side, everything else on the other for this technique. So what would you do? You'd have natural log of 4x plus 1. I'd subtract that natural log over of 3 equals, and I'd add the 5 over. This allows us to do kind of what we did in this example, number 3, right? By changing that into division. So 4x plus 1 over 3 equals 5. Change this into exponential form. Now always remember natural log means I have e involved here, right? So I'd have e to the 5th equals 4x plus 1 over 3. Now you need to solve for x, so I'd multiply both sides by 3, subtract 1 and divide by 4. That's going to give me x equals 3e to the 5th minus 1 all over 4. And I can either leave it like that, or if I ask you to round, you'd have to approximate that. Put that in your calculator. What do you get? You end up getting 111.1, depending on how I ask you to round that. Okay, and will that work when I plug it in here for x? Yes, you're going to get a ginormous number, but as long as it's not 0 or negative, you are fine. All right, last two here. First thing I would do is before I go simplifying this side, I would deal with this 2 out front, which this time we're not going to divide both sides because then this log base 9 of 6x minus 3 would be affected. So instead make it a power, which means I'm squaring that thing, which gives me log base 9 of x, right? Square root of x times square root of x is just x, minus log base 9 of 6x minus 1 equals 0. Now I can divide those two things. There we go. So that becomes log base 9 of x over 6 minus x equals 0. Now, don't have another log on the other side, so next take it back into exponential. 9 to the 0 equals x over 6x minus 1. Now what? So this is just 1, right? And so how do I solve this? 1 equals x over 6x minus 1. Well, if I cross multiply or multiply both sides by 6x minus 1, I'll get 6x minus 1 equals x, and then just solve from there. So I would get negative 1 equals negative 5x. Divide